implement eBGP for IPv4. This topology. Okay, routers. You can use Cisco 7200. Okay, I have the Cisco 7200 with iOS 15.2. I will use 3 routers, R1, R2, and R3. The connections between R1 and R2 gigabit 000. I will use the connection gigabit 00 and gigabit 00. Between R2 and R3 gigabit 001 and gigabit 000. In this case, I will use gigabit 10 and 00. Between R1 and R3, 2 serial interfaces from serial 010 to 010 and from serial 011 to serial 11. I will use serial 30, 30 and 31 to 31. Addressing table. You will configure eBGP for IPv4. Build the network ready, cable the network ready, configure basic settings for each router. Okay, first start the devices. Start R1, R2. R2, R3. Copy the basic configurations to a notepad. I will make some modifications. Router R1, hostname, no IP domain lookup, line console, loopback 0, loopback 1. But in my case, interface gigabit 000 is only 00. Okay. Only on R1 gigabit 00, and interfaces serial 30 and serial 31. Serial 30 and serial 31. Router R2. Okay, loopback 0, loopback 1, gigabit 00. And instead of using gigabit 001, I am using gigabit 10. Okay, instead of 001 is 10. 10. R3, loopback 0, loopback 1, gigabit 00, serial 30 and serial 31. Okay, on R3, 00, 30, serial 30 and serial 31. Okay, go to R1, double click. Configure terminal. Okay, on global configuration mode, copy the basic configurations. Copy, right click to paste. Okay, very good. No errors, no issues. R2, double click. Configure terminal. Copy. Right click to paste. Okay, very good. R3. Copy. Configure terminal on global configuration mode. Right click to paste. Okay, very good. Configure and verify eBGP for IPv4 on all routers. Implement BGP and neighbor relationship on R1. Enter BGP configuration mode from global configuration mode, specify as autonomous system 1000. Okay, autonomous system 1000. R1 has the autonomous system 1000. So on R1, configure router BGP 1000. Autonomous system 1000. There is BGP. Enter. And set an ID 1, BGP router-ID 1. Based on the topology diagram, configure all the designated neighbors for R1. Okay, who are the neighbors? First neighbor is this autonomous system 500, and the neighbor is 10122. 10122. Autonomous system 500, the neighbor 10122. Neighbor 10122, remote autonomous system 500. Okay, and for the another neighbor 10.1.3.3 autonomous system 300. 10.1.3.3 autonomous system 300. Okay. And 10.1.3.130. 10.1.3.130 autonomous system 300. 10.1.3.130 autonomous system 300. And advertise the IPv4 prefixes local to autonomous system number 1000. So I have two. These networks, these local networks advertise this, advertise the network address of loopback 0 and loopback 1. Network 192.168.1.0. The mask is 27 is 255, 255, 255, 224. And the another is 64. 25 is 192. Okay, the same on R2. The autonomous system is 500. Router BGP 500. Okay, two networks and two local. The router ID BGP router ID 500. BGP router ID 2. BGP router ID 2. Two networks and two networks. The first network is 10.1.2.1. 10.1.2.1 autonomous system 1000. Network 10.1.2.1 remote autonomous system 1000. Okay, and now you can see the adjacency with the another side and the another network 10.2.3.3 autonomous system 300. 10.2.3.3 autonomous system 300. And the local networks loopback 0 and loopback 1. Okay, 27 and 26 prefix. Network 192.168.2.0 mask 255, 255, 255, 224. And network 2.64 mask. Okay, for 26 is 192. Okay, R3. The autonomous system here is 300. Router BGP 300. BGP router ID 3. Okay, it's BGP. Unlike the configuration on R1 and R2, disable the default IPv4 unicast behavior. No BGP default IPv4 unicast. Okay, no BGP default IPv4 unicast. The default behavior in iOS is BGP default IPv4 unicast. Routers are wagoners who were configured using this default behavior. The BGP default IPv4 unicast command enables the automatic exchange of IPv4 address family prefixes. When this command is disabled using no BGP default IPv4 unicast, BGP neighbors must be activated within IPv4 address family AF configuration mode. BGP network commands must also be configured within IPv4 address family mode. Based on the topology diagram, configure all the designated neighbors for R3. Okay, 3 neighbors. Okay, the first neighbor, 10232, Autonomous System 500. Neighbor 10232, Remote Autonomous System 500. The another neighbor 10131, Autonomous System 1000. 10131, Autonomous System 1000. And 1013129, Autonomous System 1000. 1013129, Autonomous System 1000. Okay, now verify BGP neighbor relationships. Examine the routing tables on each router. Notice that R1 and R2 are receiving BGP prefixes from each other, but not receiving BGP prefixes from R3. And R3 is not receiving any prefixes from R1 or R2. This is because R3 was configured with using no BGP default IPv4 unicast, and the interfaces must be activated within IPv4 address configuration mode. Okay, go to R1 and show IP route, BGP, and pipe. Okay, pipe begin gateway. Okay, show IP route. Okay, 2 BGP routes. Show IP route BGP begin gateway. Sorry, is gateway with G uppercase. Okay, very nice. 2 show IP route. 2 BGP entries. 2 BGP routes. Show IP route BGP begin gateway G uppercase. Okay, G uppercase is 2 BGP routes, 20 and 264. 20 and 264. But you don't have the routes to local networks on R3. Okay, go to R2 and show IP route BGP pipe begin gateway. Okay, 2 BGP routes, 10 and 164. Okay, on R2 you can see 10 and 164. And on R3, nothing to show. And show IP route. Okay, only directly connected networks. This can be further verified by examining the BGP neighbor adjacencies on R2. Notice the BGP state between R2 and R1 is established, while BGP state between R2 and R3 is idle. Okay, go to R2, show IP BGP neighbors, space, 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 space. And show IP BGP neighbors, the neighbor with 10.121 autonomous system 1000. Okay, 10.121 autonomous system 1000. Okay, the remote router ID for R1, state established, and the another neighbor 10233 autonomous system 300, 10233 autonomous system 300, BGP state either. Okay, and also you can see external link for one neighbor, and for the another neighbor is external link. So that's why it's eBGP. Okay, eBGP, external BGP. Okay, the interfaces on R3 need to be activated in IPv4 address family configuration mode. The neighbor active command in IPv4 address family configuration mode is required to enable the exchange of BGP information between neighbors. This will enable R3 to form an established neighbor adjacency with both R1 and R2. Additionally, because BGP default IPv4 unicast is disabled, network commands must be configured in IPv4 address family configuration mode. Okay, on R3 configure. Okay, but go to BGP router configuration mode. Configure terminal, router BGP 300. Now you are on router configuration mode, and address dash family IPv4, and enable the adjacency. Okay, the first adjacency with 10.131 and 10.13129. Okay, enable 10.131 activate, and 10.13129 activate. And now the another neighbor 10.232 neighbor 10.232 activate, 10.232 activate, and notify advertise the local networks 3027 and 364.26. Okay, but you can see the adjacencies with the neighbors. Okay, 3 neighbors and 3 adjacencies, and network 192.168.30 mask. 55 to 55 to 55 to 24. And network 3.64 mask 192. Okay. And now verify that all BGP speakers are receiving prefixes from their neighbors. The prefixes from R3 are highlighted in the routing tables of R1 and R2. Okay, on R1, verify, go to R1, show IP route BGP begin gateway. Now you can see four BGP routes, 20264 and 30364. Okay, on R1 you can see 20264 and 30364. On R2 show IP route BGP begin gateway. Okay, 4 BGP routes, the networks on R1, the networks on R3. On R3 and show IP routes for BGP networks on R1 and networks on R2. Verify the state between R2 and R3. It has now been established. Okay, on R2, repeat the command show IP BGP neighbors. Okay, the neighbor R1 state established space. Then another neighbor with R3 with ID R3 10233 10233 R3 and BGP state established. Examine the running configs. Examine the running configs on all three routers because router R3 was configured using no BGP default IPv4 unicast command. Notice that the network commands are automatically entered under the IPv4 address family. This is the same configuration mode where the neighbors were activated to exchange BGP information. Okay, on R1, show running config section BGP. R1, show running config pipe section BGP. Okay, G, don't forget the G. Okay, very nice. The autonomous system 1000 ID, the local networks and the neighbors. The same command on R2 to verify. Show running -config pipe section BGP. Okay, 500 router ID, local networks, neighbors. And on R3 will be different. Show running -config pipe section BGP. Okay, now the autonomous system ID, no BGP default IPv4 unicast, 3 neighbors. But on address family configuration mode, advertise the networks and set and activate the neighbors. Okay, on router configuration mode, on BGP router configuration mode, you are specifying the neighbor and the autonomous system. But on address family, you are specifying the local networks and activating the neighbors. Okay, very good. verify BGP operations. On R2, show IPBGP. R2, show IPBGP, BGP. Okay, and now you can see this table. The destination network 192.168.1.0, and you are on R2. You are on R2, and the destination is 192.168.1.0. Okay. Okay, and to reach this network 192.168.1.0, you have two paths. Okay, the first path 10.2.3.3. Okay, 10.2.3.3. Okay, you can see from R2, the next is R3, and next R1 to reach 192.168.1.0. And then another path 10.1.2.1. Then another path 10.1.2.1 to reach this network. Okay, the first path through Autonomous System 300 and then Autonomous System 1000. The first path first go to Autonomous System 300 and then Autonomous System 1000. But another path is directly to 1000. Okay, another path goes directly to Autonomous System 1000. Okay, so that's why this symbol indicates that this is preferred. This is the best path, is preferred. This. Okay, another example. The network 192.168.3.64. Remember, you are on R2 and the destination network is 192.168.3.64. You are on R2 and the destination network is 192.168.3.64. And you have two paths. The first path is 10.2.3.3. First path 10.2.3.3. And goes to Autonomous System 300. Okay, Autonomous System 300. The another path is 10.1.2.1. Another path is 10.1.2.1. 10.1.2.1. And through Autonomous System 1000 and 300. Through Autonomous System 1000 and then 300. Okay, this is another path to reach this network. And obviously, the direct path is preferred with this angle bracket symbol. Okay, this path is preferred. What does the asterisk at the beginning of an entry indicate? Okay, this symbol. That means the network is reachable. The entry is valid and is reachable. What does the angle bracket in an entry indicate? This angle bracket. The angle bracket indicates that this is the best path, or the route has been selected as the best route. What is the address of the preferred NetHub router to reach 192.168.1.0.27 network? Explain. Okay, to reach 192.168.1.0.27 network, the NetHub router is 10.1.2.1. Is preferred. Okay. Okay, and it is preferred because it has a shorter autonomous system path. How can you verify that 10.1.2.1 is the NetHub router used to reach 192.168.10.27? Okay, to reach 192.168.10.27, and this is the preferred next hop 10.1.2.1. So you can show the routing table, show IP route, BGP, begin gateway, enter, and to reach 192.168.10.27, the next hop is 10.1.2.1. 10.1.2.1, the preferred next hop. Okay, and what does next hop of 0000 indicate? Okay, look at this example. To reach 192.168.20.27, the next hop is 0000. To reach 192.168.264.26, the next hop is 0000. Okay, remember you are on R2 and the networks are 20 and 264. You are on R2 and the networks are 20 and 264. Okay, so the answer is the advertised prefix is a directly connected network. Okay, if the next hop is 0000, is a directly connected network. Use show IPBGP command to display all the paths for a specific route and the BGP path attributes for that route. Okay, on R2. Okay, on R2, for example, show IP BGP 192.168.10. Okay, show IP BGP 192.168.10. The destination and two paths available. The neighbor 10.2.3.3 through autonomous system 300 and then 1000 with another neighbor 10.1.2.1 only through 1000. And you can see this is the best path, the best. Okay, this is preferred. Okay, this NetHub is preferred. What is the IPv4 address of the NetHub router with the best path? 10.1.2.1. Examine the BGP neighbor relationship on R2 using the show IP BGP neighbors command. Show IP BGP neighbors. Space, 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 space. How many neighbors does R2 have and what are their router IDs? Show IP BGP neighbors. This is the first neighbor, 10.1.2.1, and the router ID is 1111. And the second neighbor is this, 10.2.3.3 with router ID 3333. Okay, for R2 you have two neighbors, this and this. What is the BGP state of both neighbors? Okay, the first neighbor state established and the another neighbor state established. What are the keep alive and hold time value for both neighbors? Okay, the first neighbor uh, keep alive interval is 60 and hold time 180. And for another neighbor, keep alive interval 60 seconds and hold time is 180. Configure and verify route summarization and atomic aggregate. Configure route summarization using atomic aggregate. Summarizing prefixes conserves router resources and accelerates best path calculation by reducing the size of the table. Summarization can be configured either for prefixes originated by the autonomous system or prefixes received from downstream providers. Summarization also provides the benefits of stability by hiding flapping routes or having to install new prefixes when they are contained within a summary. Although Autonomous System 1000 only has two prefixes, 192.168.10.27 and 192.168.164.26. This customer has been allocated the entire 192.168.10.24 prefix. R3 in Autonomous System 300 has two prefixes, 192.168.30.27 and 192.168.364.26, but has been allocated the entire 192.168.30.24 prefix. Configure R1 and R3 to advertise a summary or aggregate route using the aggregate address command. The summary-only option suppresses the specific prefixes that are summarized from also being advertised. Notice that this command is configured in address family IPv4 configuration mode on R3. Okay, on R1, summarize, go to R1, configure terminal, router, BGP 1000, and aggregate dash address 192.168.10.285.255.250. Summary dash only. Okay, enter. Okay, 192.1.0 and 192.164 in 192.168.10 to 55.255.255.0. Okay. Okay, and on R3, configure terminal, router, BGP. The autonomous system here is 300. Okay, on R3, the autonomous system is 300. Enter to the address family, IPv4. Okay, do it on address family, aggregate dash address 192.168.30. 285, 285, 255, 0, summary only. Okay, enter. Verify route summarization using atomic aggregate. Examine the routing tables on each router to verify the route summarization for the two prefixes. Verify that R1 and R3 are each receiving the summary routes from the other router. Okay, go to R1 and verify. Okay, verify on R1 and show IP route BGP begin gateway. And now you can see the local summary is 192.168.10.24. But look at this, it's using the null zero. Okay, but these are the networks on R2, but this is the summary network on R3, 3024. Okay, go to R2, show IP route, BGP begin gateway. Okay, before you had four routes, four networks, but now you have only two, the summary networks 1024 and 3024. And go to R3 and show IP route BGP begin gateway. Now you have only one summary on R1, 181, 168.1024. Two networks on R2 and only one network on the local network 30, the summary on the local network on R3, null zero. Why do R1 and R3 contain an entry with an ad-hop address of null zero? What is the result of having this null zero route in the routing table? This is the same prefix as the aggregate route advertised by this router. The router's routing table contains more specific routes. The null zero route is a discard route for loop prevention. Any packets with a destination IPv4 address matching the aggregated prefix with the null zero egress interface but do not match a more specific route will be dropped. Examine the BGP table on router R2 to verify the route summarization. When a prefix has the default classful mask, the subnet mask is not displayed. But 192.168.10 and 192.168.30 prefixes have a 24 prefix length, which would be the default max for Class C address. Okay, on R2 show IPVGP. Show IPVGP. Okay, the table, and look at this. The network is 10 because it's classful, will not show the prefix. Two paths, but this path is preferred, the direct path. And from 30, two paths, but this path is preferred, the direct path. Okay, on R2, from R2 to reach the summary networks, this path is preferred, this path. And from R2 to reach these summary networks, this path is preferred. Examine the BGP table on routers R2 and R3 and verify that each router is receiving the summary route from the other router. Okay, go to R1. Show IPVGP. Show IPVGP. look at this. 10 and 64 are suppressed for this. And the asterisk is that it's a valid destination, a valid network, and this is the best path. Okay, both are suppressed, and this is the summary. But these are directly connected networks because the NAT hub is 000. Okay, you are on R1, and these are directly connected networks. And this is the summary route from R3. You have 3 paths to reach this network: 10.1.3.130, 10.1.3.130. Another path is 10.1.2.2, 10.1.2.2, and 10.1.3.3, and 10.1.3 and 3. And this is the best, the preferred. This is the preferred path, the best, with the angle bracket, the best. 10.1.3.3, 10.1.3.3. Okay, and the same way, verify R3. Show IPBGP. Okay, the directly connected networks 30 and 364 are suppressed. And you can see the summary route to 10, and you have 3 paths to reach this valid network. Okay, it's valid. You have 3 paths, but only one is the best. This only one is the best. Why? Do 2 of the entries have the status code of S? Specifically, this is the result of what command or option that was configured on these 2 routers. This indicated that the route was suppressed. These entries were suppressed because a summary route was advertised instead. Prefixes with a NAT hub of 0000 are directly connected networks on this router. The summary only option in the aggregate address command suppressed these more specific prefixes for being advertised. Examine the explicit 192.168.10 prefix entry in R2's BGP table. The route's NLRI information indicates that the route was aggregated in Autonomous System 1000 by the router with the router ID 1111. Okay, go to R2 and verify. Show IPBGP 192.168.10. Okay, and two paths available, and you have 2 paths. The first path is this, and the second path is this. Okay, this is the best path, this, and is atomic aggregate. Okay, aggregated by 1000, router ID 1111. Configure and verify route summarization with atomic aggregate and autonomous system set. Configure route summarization using atomic aggregate and autonomous system set. Shut down both serial interfaces on R1. This will create a single path from R1 Autonomous System 1000 to R2 Autonomous System 500 to R3 Autonomous System 300. Shut down all interfaces, all serial interfaces on R1. In my case, configure terminal. In my case, the interfaces are serial 30 shut down and serial 31 shut down. Okay, serial 30 shut down, serial 31 shut down. Remove root aggregation previously configured on R1. Okay, go to R1 and remove the configured summary exit router BGP 1000. And this is the command aggregate address 192.168.0.255.255.255.0 summary only, but add no keyword at beginning to remove. No, enter. Okay, now it's removed. Exit. Verify R3 is now receiving the non-summarized prefixes 10 and 164. Okay, go to R3. Show IP root BGP begin gateway. Okay, these are the no summarized networks on R1, 10 and 164. Okay, very good. On R2, summarize the prefixes 192.168.10.27 and 192.168.164 received from R1 as 192.168.10. Okay, on R2 configure. Remember, on R2 the autonomous system is 500. Configure terminal router the BGP 500. Okay, BGP 500. Enter. Then aggregate-address 192.168.10.255.255.255.0 summary only. Okay, 255.255.255.0 summary only. Enter. Verify root summarization using atomic aggregate and autonomous system set. And on R3, go to R3. Show IP root BGP begin gateway. Now, before you had 5 routes, now you have only 4, because 10 and 164 is now 192.168.10.24. Examine R3's BGP table. Notice that the autonomous system path only includes the autonomous system that summarized the route. Autonomous system 500 route 2. Okay, show IP BGP. Show IP BGP. And 192.168.10, the destination, the net hop 10.232. Only one net hop because serial interfaces was shut down. Serial interfaces was shut down. So from R3 to reach these networks on R1, you have only one hop 10.232. The net hop is only one 10.232. On R2, remove the current route aggregation for the 192.168.10 prefix and configure it again, this time using the autonomous system set option. Okay, on R2, exit router BGP 500, remove the previous command using the no keyword, no space, aggregate address 192.168.10.255.255.255.0 summary only, enter. But configure the new Summarization aggregate address 192.168.1.0.255.255.0 autonomous system set summary only. Okay, enter and verify on R3. Go to R3, verify, show IP root BGP begin gateway, and now look at this. Still the two subnets repeat. Okay, now BGP 192.168.1.0.24. This is the summary. Very good. And examine R3's BGP table again. Notice that the entry for 192.168.1.0 this time includes the entire autonomous system path. Okay, show IPBGP. Show IPBGP. Okay, this is a valid network and the best path to reach 192.168.1.0 from R3. From R3, you will reach 192.168.1.0. Okay, the NAT hop is 10.2.3.2. The NAT hop is 10.2.3.2. The only one NAT hop because serial interfaces were shut down. And now you can see the path through Autonomous System 500 and Autonomous System 1000. Okay, through Autonomous System 500 and through Autonomous System 1000. Okay, this is shown because you configured on R2 you configured as the summarization with autonomous system set, and go to R3 and now you can see before the destination was 192.168.1.0, the NAT hop, the only one NAT hop, but only you will show and you will see only the autonomous system 500, the autonomous system of the network 500. But with autonomous system set, you can see all the path. Okay, 500 and 1000. Configure and verify the advertising of a default route. Configure default route advertisement on R2. Configure R2 to advertise a default route there to R1. R2 does not necessarily have to have a default route to its own. Core Internet routers that have full Internet routing tables and do not require a default route are referred to as being in a default-free zone, DFZ. Okay, on R2, configure router BGP 500. Exit router BGP 500. The neighbor is 10.1.2.1. You are on R2. The neighbor is 10.1.2.1. And default-originate. Enter. And verify on R1. And show IP root BGP begin gateway. Okay, wait a moment again. on R1 you should see on R1 you should have this this entry. Okay, on R1 show IP route BGP begin gateway. Okay, now wait a moment, and now you have the entry at the default route using BGP, and show IP BGP on R1. Show IP BGP, and now you have the network is internet or the default route 0000, next hop 10.122. For R1 the next hop is 10.122. Okay. Thank you very much.